Hello and welcome to Summarize Science. With NASA, ESA, and other space agencies planning missions back to the moon, a fascinating and fundamental problem has come up. What time is it on the moon? It sounds simple, but it's a huge challenge that scientists are working to solve right now. Because of Einstein's theory of relativity, time is not absolute, it's relative. Time flows at a different rate depending on gravity and your speed. A clock on the moon's surface actually ticks slightly faster than a clock here on Earth. This isn't just a quirky fact. For future lunar bases and satellites to navigate and communicate, everyone needs to be on the exact same time, down to the nanosecond. To solve this, the International Astronomical Union has defined a theoretical time standard called Lunar Coordinate Time, or TCL. This paper investigates the best way to turn that theoretical idea into a practical, usable time for astronauts and robots. The researchers analyzed three main options for a practical lunar time. Option 1 is the simplest. Just use the theoretical TCL directly, with no adjustments. Option 2 is to create a scaled version of TCL so that its rate matches the average rate of a physical clock on the moon's surface. This is similar to how we defined terrestrial time here on Earth. However, as this map shows, the rate can still vary slightly depending on your altitude in lunar mountains or craters. Option 3 is to scale lunar time so that it stays perfectly in sync with Earth time over the long term, with no secular drift. This would make coordinating between mission control on Earth and explorers on the moon seem a little more direct. So, which is best? The paper reveals a major hidden complexity. Scaling time isn't that simple. If you choose option 2 or 3, you also have to scale your values for mass and distance in every single physics calculation to make the math work. This would create extra sets of constants and could lead to major confusion and errors, especially when calculating things between the Earth and Moon. But what about the clocks themselves? The researchers point out that just like GPS satellites orbiting Earth, any high-precision clock on the moon will need to be actively adjusted, or steered, to match the official reference time anyway. Because of this, the supposed benefit of scaling the time to match a local clock becomes much less important. After weighing these issues, the paper reaches a clear conclusion. The authors recommend option 1, using the pure, unscaled Lunar Coordinate Time, or TCL. To recap, the main reason is that the other two options introduce a messy web of scaling for mass and distance, making calculations far more complex. Furthermore, the argument for scaling time to help local clocks is weak, since high-precision clocks will need to be actively steered to the official time no matter what. The simplest, most direct, and least confusing solution is to just use TCL. This decision is a critical step in building the infrastructure for a permanent human presence on the moon, ensuring everything from navigation to communications works flawlessly. Thanks for watching Summarize Science.